Okay, I was asked about problems like this, right? We have to use this notation, this sum notation, and the limit notation instead of integral notation. So remember the way this works. Here we've got this function, unknown function. Actually, we do know the function. But anyway, it goes over some interval from A to B. And the length of this interval is B minus A, right? That's the length of it, the big number minus the small number. And this interval is divided into a bunch of subintervals. Okay, and then you sum the width dx of each subinterval times the height, which is f of whatever number this is. And that'll give you the y value, and you sum a bunch of products, a bunch of areas, and you get an area under the curve, right? So anyway, let's look at this. We're summing a bunch of areas, right? And this is the height, and that's the width, right? And it's the same way. There's the width, there's the width, there's the width, and this is the height, and that's the height, and that's the height. And you can see all the heights use the same function. You just have to plug in different numbers in for x, and the numbers you plug in are all between 1 and 3, okay? So the width, let's talk about that. The width, if we have the number of subintervals, right? The number of subintervals. So let's say the number of subintervals, if you're doing RAM 5, then n would be 5. And the width of each one of these rectangles is the length of the whole interval, b minus a, and you divide it by 5, and that's the width of each one of these, right? So if we look at this top number here for the width has to be the length of the interval. Since the interval goes from 1 to 3, we need it 2 divided by the number of subintervals. So it cannot be C and it cannot be A, since that number up there has to be 2. Okay? So let's talk about the height. The height changes by putting numbers from 1 to 3 in for x. And then you square it, and then you add 2, and then you take the sine of it, and then you get the height, right? So this number right there has to be numbers in between 1 and 3. And if we plug in a number there without starting at 1, we're going to get the wrong number. And let me tell you just a little bit more. K right here is like a counter. It counts the number of subintervals that you're on. So if you're on the 4th subinterval, we're going to be on this one, and we're going to calculate the rectangle by plugging in the number that's added to the bottom of the subinterval, the number that we're going to plug in for x, right? We want to be that far from the left side of the interval, okay? So look at left side of the interval. This 2 over n is the width of each subinterval, and the k tells you it's the kth rectangle. Okay, so when we're doing these problems, a couple of things you have to notice. The length of the interval, that has to be above the n, okay? And k times the width of that rectangle has to be added to the bottom of the interval. So you can tell by now that this is D, okay? And if we look at 6, it's really similar, right? Except you're going the other way. You have to find out which integral it is. But here again, this is the width, and this whole thing is the height. So we're plugging different numbers into the function. Okay, so this 2 plus, remember, it's just like that 1 plus. The 1 is the bottom of the interval. Right? So this 2 has to be the bottom of the interval. The width of the interval, the width has to be 3. So 2 plus 3 is 5. So this integral has to go from 2 to 5. Oh, it's the only one that does. Okay, and then this 3, width of the interval divided by n, same thing, is how wide each rectangle is in the kth one. Tells you, which rectangle you're on. Okay, so that would do it. It is this one. Okay, hopefully that makes sense.